I'm going to consolidate and condense down the essential concepts that I've been covering on this channel and start expanding into some non-functional programming topics that will help draw a contrast between the two in future videos. Consider this video a checkpoint in your journey towards functional programming enlightenment. Most of the topics I'll be summarizing here have prior videos to watch for those who want a deeper dive and refresher on the subjects. Not too bad for a barely functional dev. To start off, we have values. Most of you are familiar with these, but to reiterate, values are a specific quantity or aggregations thereof. The number 42 obviously qualifies. An array or list of the numbers 1, 2, 3 also counts. The string hello is an aggregation of encoded characters. Object values are nested aggregations of keys and values. Values cannot change and are therefore called immutable. Values always remain consistent and can be conveyed to be perceived at any time. This means that you can pass values around and read them from anywhere, risk-free. Next, a constant is an alias for a value within a computer program. Okay, moving on. Functions define how one set of values, that is the inputs, arguments, or domain, relates to another set of values, that would be the outputs, return, or range. They're a shorthand for an aggregation of values, such as an object value that maps each input to an output. For a much deeper dive and explanation on functions, see my very first video on this channel. Okay, next. An expression is either a single value or a representation with placeholders that can be evaluated to a value. Writing code using expressions is programming by intended result. Expressions are not concerned with how they are evaluated. That's the computer's job. Functions are actually aggregations of expressions. Now, statements, on the other hand, are instructions to execute that result in no value. Examples include assignment statements, if, for, and switch statements. Using statements is programming by ceremony and requires thinking like a machine. This is how you would instruct a 5-year-old, or anyone else you didn't trust, what you want them to do. For more information on statements versus expressions, see this previous video. Now, let's start venturing into new territory, starting with something I'm going to call a place. Places are a portion of computer memory that can be written to and read from, making them mutable by nature. A place can be assigned a value, but that only persists if the place is not reassigned. These are sometimes called state in a computer program. So unlike values, once conveyed, places can be perceived in an inconsistent state while being written to. Statements perform all their work with such places. Okay, a variable in a computer program is just an alias for a place. So the next concept has many names it's called. Sometimes they're called properties, other times fields, or perhaps attributes. The thing that they all have in common is that they are variables given to places that are contained within another place. This leads to a hierarchy of places and makes inconsistencies between them more likely to happen. Next up, we have methods, which are sort of like functions, except not at all. So in addition to expressions, methods support writing statements, and they also come with a context that changes depending on where they're called, usually referred to as this or self. So with all these building blocks we've just created, we're able to establish now what a class is from object-oriented programming paradigm. Classes consist of a definition of how to initialize a place with properties using a method called a constructor, along with other methods that should be bound to the context of that place. Once this place has been operated on by the code for the class, it is called an instance. Okay, going to move on to a different topic now. For the purposes of programming, time can be thought of as an ordered set of states. Imperative programming refers to writing programs with statements. These directly translate into machine code that the computer can execute. The resulting program is what I would call time-oriented and stateful by design. On the other hand, declarative programs are written with expressions. They define the what and not the how of the program. The resulting program is what I would call time-free and stateless. Just a few more concepts to cover, and then we'll wrap up for now, I promise. Okay, cognitive load refers to the mental effort required to understand a thing. An example of low cognitive load is, say, the concept of simple, which means literally one-fold. Simple is focused on doing or thinking about one thing at a time. Examples of simple include values, expressions, and declarative programming. Now, by contrast, complex is multiple things woven together. The result is scattered and tries to do many interrelated things, resulting in high cognitive load. Examples of complex things include statements, places, variables, methods, classes, and imperative programming. For more reference, I would encourage you to check out a video by Rich Hickey of Clojure fame, which dives into simple and complex. You should all watch the video. It's called Simple Made Easy. Well, I think that's about enough cognitive load for one video. While your mind is processing all that information, hit the like button and give my channel a subscribe so you can consume all the great content I will be making in the future. And if you have suggestions for what that content should be, I'd appreciate your comment below.